What if I told you that the red, barren landscape of Mars could one day be a lush, green paradise teeming with life? What if I told you that one day humanity could walk on a planet that we've only gazed at from a distance, transforming its barren, red surface into a thriving green oasis? This isn't the realm of science fiction, but a vision of the future that scientists and engineers are diligently working towards. Welcome to the fascinating world of Mars terraforming, where cutting-edge technology and audacious dreams converge to make the impossible possible. Imagine standing on the surface of Mars, breathing in the fresh air, feeling the warmth of the sun on your skin, and gazing at the blue skies overhead. This vision is the ultimate goal of terraforming, the process of transforming a hostile environment into one that can support human life. But how do we go from red dust to green fields? Let's embark on this extraordinary journey together. Mars, our neighboring planet, has long captured our imagination. With its striking red appearance, it's a world both alien and eerily familiar. But beneath its rusty surface lies the potential for a second Earth. Mars has water ice, a day similar in length to ours, and seasons caused by its tilted axis. However, it lacks a thick atmosphere, liquid water, and a stable climate, critical elements for supporting life. The first step in terraforming Mars is to warm it up, a process known as global warming on an interplanetary scale. One of the most promising methods involves the use of super greenhouse gases. By introducing potent greenhouse gases like perfluorocarbons (PFCs) into the Martian atmosphere, we could trap more of the sun's heat, gradually raising the planet's temperature. But where would we get these gases? One idea is to manufacture them on Mars using local resources. This would involve mining the planet for raw materials and constructing chemical plants to produce the gases. Alternatively, we could send these gases from Earth, but this would be a massive logistical challenge. As the temperature rises, the frozen carbon dioxide at the poles would start to sublimate, turning directly from solid to gas. This process would thicken the atmosphere and further enhance the greenhouse effect. The increased atmospheric pressure would allow liquid water to exist on the surface, creating the conditions needed for life. However, Warming Mars and thickening its atmosphere is just the beginning. To create a truly habitable environment, we need to introduce oxygen, a critical component for human survival. One potential solution is photosynthesis, the natural process used by plants on Earth to convert carbon dioxide into oxygen. Introducing hardy, genetically engineered plants and microorganisms to Mars could kickstart this process. These pioneer species would be specially designed to withstand the harsh Martian conditions and thrive on carbon dioxide. Over time, they would release oxygen, gradually transforming the atmosphere. In addition to plants, we could deploy large-scale algae farms in bodies of water once we have successfully melted the ice caps and created stable water sources. Algae are incredibly efficient at producing oxygen and could play a vital role in this terraforming effort. Creating a breathable atmosphere is one thing, but we also need to address the issue of radiation. Mars lacks a magnetic field, which on Earth protects us from harmful cosmic and solar radiation. Without this protection, life on the Martian surface would be constantly bombarded by dangerous levels of radiation. One possible solution is to build large magnetic shields in orbit around Mars. These shields would generate a magnetic field strong enough to deflect the radiation, creating safe zones on the planet's surface. Another approach could involve constructing underground habitats, where the Martian soil would provide natural radiation shielding. As we work towards creating a habitable atmosphere and protecting future inhabitants from radiation, we also need to think about water. While Mars has significant amounts of water ice, we need to melt it and keep it in liquid form. This could be achieved through the construction of massive solar mirrors in orbit. These mirrors would reflect sunlight onto the poles, accelerating the melting process. Once we have liquid water, we would need to create a sustainable water cycle. This involves building reservoirs, lakes, and possibly even oceans. Water management systems would be crucial to ensure that this precious resource is distributed efficiently across the planet. Terraforming Mars isn't just about making it habitable for humans, it's about creating a thriving ecosystem. This means introducing a diverse range of plant and animal species, each playing a specific role in the new Martian environment. Scientists would need to carefully select species that can adapt to the Martian climate and contribute to the overall balance of the ecosystem. The introduction of life to Mars would be a gradual process, starting with microorganisms and hardy plants, followed by more complex plants and eventually animals. Each stage would be meticulously planned and monitored to ensure the stability and sustainability of the new ecosystem. The technology required for terraforming Mars is mind-boggling and would involve unprecedented levels of international cooperation and investment. space agencies, private companies, and governments would need to work together, pooling their resources and expertise to achieve this monumental task. But the rewards would be immense. Not only would we have a second home for humanity, but the knowledge and technology developed during the terraforming process could have far-reaching benefits here on Earth. We could gain new insights into climate change, renewable energy, and sustainable living knowledge that could help us tackle some of the biggest challenges facing our planet today. However, we must also consider the ethical implications of terraforming Mars. This is a planet that has existed for billions of years without human intervention. By transforming it to suit our needs, we could potentially destroy any existing Martian life forms, no matter how primitive. Scientists are divided on this issue, with some advocating for the preservation of Mars in its natural state, while others argue that the benefits of terraforming outweigh the potential risks. To address these concerns, thorough exploration and study of Mars are essential before any large-scale terraforming efforts begin. Robotic missions, followed by human explorers, would help us understand the planet's geology, climate, and potential for life. Only with this knowledge can we make informed decisions about the future of Mars. The journey to a habitable Mars would be long and fraught with challenges, but it is a journey worth taking. It represents the next great leap for humanity, a chance to prove that we are not confined to Earth, but are capable of reaching out and shaping other worlds. It is a testament to our ingenuity, our determination, and our unquenchable thirst for exploration. The dream of transforming Mars into a habitable world is one that captivates our imagination. But as with any great endeavor, the devil is in the details. Previously, we explored the broad strokes of what it would take to terraform Mars, warming the planet, creating a breathable atmosphere, and introducing life. But how exactly do we make these ideas a reality? What technologies will we need, and what challenges lie ahead? One of the most crucial steps in terraforming Mars is warming the planet, a task that requires massive energy resources. We previously discussed the idea of using super greenhouse gases to trap heat. But how do we deploy these gases on a planetary scale? Enter the concept of orbital mirrors. These mirrors, made of ultra-lightweight materials like mylar, could be placed in orbit around Mars to reflect sunlight onto specific areas of the planet, such as the polar ice caps. By focusing sunlight in this way, we could accelerate the melting of ice and increase the amount of carbon dioxide in the atmosphere. This would not only warm the planet, but also help to thicken the atmosphere, making it more Earth-like. Constructing and deploying these mirrors would be a monumental engineering challenge. They would need to be enormous, perhaps hundreds of kilometers across, to have a significant impact. However, with advances in materials science and space technology, such a project is not beyond the realm of possibility. Imagine fleets of robotic spacecraft assembling these giant mirrors in orbit, working tirelessly to reshape the destiny of an entire planet. But warming the planet and thickening the atmosphere is just the beginning. To truly make Mars habitable, we need to address the problem of oxygen. We touched on the idea of using genetically engineered plants and microorganisms to produce oxygen through photosynthesis. However, this process would be slow, taking centuries or even millennia to reach breathable levels. So, how can we speed things up? One promising solution is artificial photosynthesis. This technology mimics the natural process used by plants, but does so much more efficiently. Using solar panels, we could power devices that split water into oxygen and hydrogen through a process called electrolysis. The oxygen would be released into the atmosphere, while the hydrogen could be stored and used as fuel. To make this a reality, we would need to establish a network of solar farms across Mars. These farms would be equipped with advanced electrolysis units, continuously producing oxygen and slowly but steadily transforming the atmosphere. While this technology is still in its infancy on Earth, the harsh conditions of Mars could provide the perfect proving ground for its development. Another intriguing idea is the use of microorganisms known as extremophiles organisms that thrive in extreme environments. Some extremophiles on Earth can survive in highly acidic or radioactive environments, conditions that are similar to those found on Mars. By engineering these organisms to produce oxygen or other gases beneficial to terraforming, we could harness their resilience to help transform the Martian environment. But even if we succeed in creating a breathable atmosphere, there's still the issue of radiation. Mars's thin atmosphere and lack of a magnetic field leave its surface exposed to harmful cosmic rays and solar radiation. Without proper protection, life on Mars would be at constant risk. As we discussed earlier, one solution is to construct large magnetic shields in orbit around Mars. These shields would generate a magnetic field strong enough to deflect radiation, much like Earth's magnetosphere does. The technology to create such shields is still theoretical, but research into plasma physics and magnetic confinement could one day make it possible. In the meantime, we might need to rely on more immediate solutions, such as building underground habitats. By living below the surface, future Martians could be shielded from radiation by the planet's soil. These habitats could be constructed in natural caves or lava tubes, or we could dig our own tunnels and chambers. building underground also offers other advantages. The stable temperatures below the surface would provide protection from the extreme temperature swings on Mars's surface. In addition, underground habitats could be more easily pressurized, creating Earth-like conditions for their inhabitants. Imagine entire cities hidden beneath the Martian surface, connected by a network of tunnels and transportation systems, a thriving underground world, safe from the harsh conditions above. Of course, living underground is not an ideal long-term solution. As we continue to terraform Mars, we would eventually want to establish surface habitats where people could enjoy the open skies and landscapes of the newly transformed planet. These habitats would need to be built with radiation shielding in mind, possibly incorporating thick walls made of Martian regolith or advanced materials that can block radiation. But what about water? Liquid water is essential for life. And while Mars has plenty of water ice, turning that ice into liquid water is a complex challenge. In addition to melting the ice with orbital mirrors or other heating methods, we would need to establish a sustainable water cycle on Mars. This could involve creating artificial lakes, rivers, and oceans, using the melted water to shape the landscape of Mars. We could also develop systems to collect and recycle water, ensuring that every drop is used efficiently. But advanced filtration and purification technologies would be crucial, especially in the early stages of terraforming, when water would be a scarce resource. One idea is to create vast underground reservoirs where water could be stored and protected from evaporation or freezing. These reservoirs could be connected to a network of pipelines and irrigation systems, distributing water to different parts of the planet. Over time, as the atmosphere thickens and the climate stabilizes, we might even see rain on Mars, an incredible milestone in the terraforming process. However, water isn't just for drinking and irrigation. It's also a key component in creating the conditions necessary for a stable and thriving ecosystem. As we introduce plants and animals to Mars, they will need water to survive. But they will also play a crucial role in maintaining the planet's water cycle through processes like transpiration and evaporation. Creating a balanced ecosystem on Mars is perhaps the most complex and delicate part of the terraforming process. It's not just about introducing life, but about creating the right conditions for life to flourish. This means carefully selecting species that can thrive in the Martian environment and ensuring that they interact in ways that support the overall health of the ecosystem. For example, we might start by introducing hardy pioneer species plants and microorganisms that can survive in harsh conditions and help to build soil. As the environment becomes more hospitable, this process would require constant monitoring and adjustment as we learn more about how life on Mars behaves and evolves. It's a dynamic, ever-changing system, and we would need to be flexible and adaptive in our approach. It's a long-term vision, one that requires patience, persistence, and a willingness to think on a planetary scale. But the potential rewards are immense. Not only would we create a second home for humanity, but we would also gain invaluable knowledge and experience in planetary engineering knowledge that could help us address some of the most pressing challenges here on Earth. Scientists and ethicists are grappling with these questions, and there are no easy answers. Some argue that we should leave Mars untouched, preserving it as a natural laboratory for scientific exploration. Others believe that the potential benefits of terraforming outweigh the risks, and that by transforming Mars, we are fulfilling our destiny as a spacefaring species. Ultimately, the decision to terraform Mars is one that will need to be made by future generations. It's a decision that will require careful consideration, informed by the best science and guided by a deep respect for the natural world. But one thing is certain: the dream of transforming Mars into a living, breathing world is one of the most ambitious and exciting projects ever conceived by humanity. As we look to the future, we are reminded of the words of Carl Sagan, who once said, "The exploration of the solar system is a human enterprise, an adventure that reflects our noblest aspirations." Terraforming Mars is the ultimate expression of those aspirations, a bold leap into the unknown, driven by our insatiable curiosity and our desire to create a better future for all. As we gaze up at the night sky and see the red dot of Mars shining down on us, let us remember that this distant world could one day be our home. The dream of terraforming Mars is more than just a scientific endeavor. It is a bold statement of human potential, a declaration that we are not content to merely survive, but to thrive, to explore, and to create. Until next time, keep looking up and dreaming big.